Hi, I'm Deirdre from the Business Insight Company. In this video, I will give you the basic foundation theory behind Stardust. Stardust is the segmentation module of TIMi. Stardust allows you to visually explore on your computer screen the entire studied population. This visual exploration allows you to find interesting figures about your data, detect outliers and non-valid data, find segments of customers having similar behavior, and discover hidden patterns inside your data. Let's directly illustrate the study using the classical census income database that we have already seen. Each row of the census income database is an individual. Here is an extraction of the database. For each person we know several pieces of information: age, education, marital status, race, sex, country of birth, weeks worked in year, and so on. We can represent this database graphically in the following way. Each dot on the screen is an individual. The coordinates of one dot, one individual, are x as the age, y as the capital gain, and z as weeks worked in year. We could have used other information about the individuals to obtain a 3D coordinate, because the 3D coordinate is, in the end, only three numbers, and these three numbers could come from any other column present inside the dataset. We could have used number of people working for an employer, capital losses, dividends from stocks, wages per hour. There are 7 numerical variables for each individual inside our dataset, so we could represent an individual by a point with some coordinates in 7 dimension. Unfortunately, the human eye can only see in 3 dimension, so we could only select 3 columns: the age, the capital gain, and the weeks worked in year. If we want to represent an individual exactly, we need to be able to see in not only 3D but 7D, so it's not possible. But there is a trick. The common trick is using a PCA. PCA stands for Principal Component Analysis. The PCA is a common trick to do dimensionality reduction. So how to use the PCA to do dimensionality reduction? Let's give an example. We have here many points in 2D, 2 dimension, and we want to reduce the dimension to 1D. For the census income database, we have points in 7D and we want to reduce the coordinates in 3D. The output of the PCA analysis is a set of different perpendicular directions. Here we have PCA1, that is the first direction, here, and PCA2, that is the second direction. When we project all the points of the database on the PCA1 axis, we obtain a new dataset that is represented here in blue. And this new dataset can be seen in 1 dimension along the PCA1 direction. We just reduced the dimension. The 2D points are now in a 1-dimensional space. During the dimensionality reduction, we didn't lose too much information because we didn't have to move the points too much during the projection. In other words, the green lines here are short. Here is another example. We start from 3D points and we want to reduce the dimension to 2D. The points in 3D are in blue. The projection of the points on the floor are represented with green lines. The PCA1 and PCA2 axes are in red. Let's project all the 3D points on the plane defined by the PCA1 and PCA2 axes. The points after projection are in blue. The projection direction in itself is in green. Please note that the distance between the points before and after projection is very small, so we don't lose much information when we're projecting all the points in the PCA plane. We didn't disturb the true original position of the points too much when projecting. This is another view of the projection. Once again, we can see that there is very little information lost in the projection. The 3D points are now in a 2D space formed by the PCA1 and PCA2 axes. We just reduced the dimension from 3D to 2D without losing too much information. So, to summarize, the PCA is a technique that allows representation of high-dimension points into a lower-dimensional space. The first PCA axis are defining privileged directions that are the best directions on which to project in order to lose as little information as possible. Let's consider another example. We still want to reduce the dimension of the 3D points to only 2D. Please note that there are 2 different families of points, the crosses and the circles. Let's project all the 3D points on the plane defined by the PCA1 and PCA2 axes. The points after projection are represented in blue. The projection direction in itself is in green. The PCA is working fine, and after projection we can still differentiate the 2 families of points. The crosses are far away from the circles. The PCA allows us to visually find segments inside the population. You can easily see the segments after a projection on the PCA axes. What happens if we use some other directions than the PCA directions to perform dimensionality reduction? Let's project all the 3D points on a randomly chosen plane. The points after projection are in blue. The projection direction in itself is in green. Note that the green lines are very long. It means that this is a very bad projection because the position of the points before and after projection are very different. After projection, we cannot differentiate the two families of points anymore. The crosses are now mixed with the circles. This is a really bad dimensionality reduction because we lost so much information that we're not able to see any segments anymore. Let's go back to the census income database. For each individual, we have 7 variables, 7 numbers. Thus, each individual is a 7D, 7-dimension point. We will project these 7D points into 3-dimension using the PCA technique. This is the result of the projection that is automatically delivered by Stardust. Using Stardust, you can directly see for yourself the 3 segments inside the dataset. By simple visual inspection, you discover existing natural segments inside your population. You can even see that here some people are outliers. A brief reminder, a complete segmentation analysis involves 2 steps. First step is creating a segmentation model, and we just had a brief overview of this part. The second step is to describe each segment from a business perspective, and we will soon see how to do that with Stardust. To summarize, PCA is used to do dimensionality reduction, and PCA is used to create segmentation models. We did not cover this topic yet. Please see the second part of this introduction to the PCA techniques to know more about this subject. The second generation data mining software, TIM, Stardust module, allows you to easily segment your customer base by using the most advanced state-of-the-art segmentation methodology. The future of database marketing starts right now with TIM. For more information, please visit our website at www.business-insight.com.